chapters, we introduce a very important idea, and that is solving equations in one variable. Now we're going to start off with a bunch of properties. Most of these you've already seen before. You've had these in previous classes, but this will be a review. And section 2.1 is properties and operations. Now the two key words that I'm going to start off with are the words commute and associate. Commute means to change locations. When people commute from work from one town to another, they're changing locations. Associate, group together. If you associate with a certain group of friends, you group them all together, you hang out together. So the commutative property has to do with changing location. The associative property has to do with grouping together. There are two commutative properties. The commutative property of addition says for all real numbers a and b, a plus b is equal to b plus a. And you realize that right away when you were learning your addition facts, that it didn't matter what order the two numbers were that you were adding. 7 plus 2 was the same as 2 plus 7. The commutative property of multiplication says pretty much the same thing, but for multiplication, for all real numbers a and b, that a times b, remember ab means a times b, is equal to b times a. When there are two variables next to one another with no symbol between, that means multiply. Now you can see there are no commutative properties for subtraction, because 7 minus 2 is not the same as 2 minus 7, nor is there a commutative property for division, because 18 divided by 2 is not the same as 2 divided by 18. Those are different values, but it works very nicely. I remember it. CO, commutative, CO, change order. It's changing the order of the two things that you're adding or multiplying. The associative property of addition, this has to do with grouping together. You will see that when you're adding three numbers, for all real numbers a, b, and c, a, b, c, a, b, c, the order did not change. When you're adding three numbers, it doesn't matter if you add the first two first or the last two first, you get the same answer. Similarly with multiplication, the associative property of multiplication says for all real numbers a, b, and c, that if you're multiplying, and again, notice the order did not change, a, b, c, it's what you group together. Here you group together the first two factors, here are the last two factors. The quantity a times b, all that times c is equal to a times the quantity b times c. This comes in handy from time to time. You probably use these properties and don't even realize what property you're using, or not even think about the name of the property, but it's something that you will use in the course of doing a bunch of algebra and a bunch of arithmetic. Here's an example. Mr. Fechner collects homework papers in 3 classes from 28 students, 25 students, and 22 students. How many papers did he collect altogether? So if I write down 28 plus 25 plus 22, I'm going to change the order here. I'm going to use the commutative property of addition here. I'm going to write this as 28, the first one I'm staying the same, plus 22 plus 25. The reason I'm doing that is if I add those two numbers, I can do that in my head because it comes out to a nice round amount. This is 50. So I add 50 plus 25 or 75. Now this is not the only way you could work the problem. You could go straight across. 28 and 25 is 53, 53 and 22 is 75. I'll get the same answer, but it makes it a little bit more convenient when you have the numbers in a particular order. Okay, we'll apply some of those properties. First, evaluate 5xy when x equals negative 9 and y equals 4. So I'll substitute that in. The negative 9 is going to go in here. The 4 is going to go in here. And I have 5 times negative 9 times 4. Now I can multiply from left to right, but I know that 5 times 4, I can do that right away. So what I'm going to do is I'm going to commute these two here. I'm going to write this as 5 times 4 times negative 9. Change the order of the multiplication, then that's 20. 20 times negative 9 is negative 180. And that's a lot easier. By the way, notice the notes up there. I want to remind you again, you should be taking notes on these properties, especially because this is going to be stuff you'll see on the proficiency test very soon. Evaluate. Evaluate here, again, we're using the associative and commutative properties to make this a little bit easier. Not that we can go and use our order of operation, but what I'm going to do here is I am going to change the order here. I'm going to write this as 36 plus 17 plus 13. And then I'm going to use the associative, and I'm going to group these together. I'm going to get 36 plus 17 plus 13 in parentheses there. This is going to be 36 plus, now see I can do that in my head, 17 and 13 is 30, and that's 66. Not a tough problem, but when the numbers get bigger, if you can get certain combinations you can do in your head, that'll make it a little bit easier for you. Same thing goes here, very much like the first example. I'm going to change the order here, use the commutative property. This is going to be 8 times 5 times negative 3, because 5 times 8 comes out to be a nice round number. That's 40. And 40 times -3, that's -120, and that's an easy one to get. Here's another good example where I might use the commutative property. If I change the order here, I notice that this number and this number will come out to be a nice round amount. This is going to be 3.4 plus 6.6 plus 9.7. Now if I add those, that's just 10, and 10 plus 9.7, that's 19.7. That comes out to a nice round amount. They're a nice easy problem. Now it says simplify the expression. I'm still using the properties, but I'm going to simplify, and here I'm going to use the commutative property. Now I'm making mention that this is the commutative property. You can see I'm adding, so it's the commutative property for addition. I'll change the order. I'll write this as k plus 7 plus 5, and I'm going to combine these using the associative property because they're similar kinds of things that can be added. They're called like terms, and we'll talk about that later. This is 12. So I get k plus 12. Now I can't add a k and a 12 because they didn't give me a value to substitute in for k, and k is a variable, not a number, until they give me a value I can plug in. Similarly, I'm going to use the associative property of multiplication here. I'm going to write this as 6 times -4, all that times b. That's -24 times b. Now again, I don't have a value to plug in for b, so that's as far as that one's going to go. I can't simplify it any more than that. And similarly, here, what I'm going to do is I'm going to write this as, I'm going to change the order of the two things, this and this. I'm going to write this as 10 times 10b. And then I'm going to use the associative property, write this as 10 times 10 times b, or 100b. Now you're looking at this and you're saying, well, all I'm doing is just multiplying the numbers, I'll do that. I'm multiplying the numbers, I'll do that. I'm adding the two numbers, I'll do that. These are the reasons why you can do that, or the commutative and associative properties. Very important property is also the identity properties. I've kind of broken it down into the two parts. This is the identity property of addition, the identity property of multiplication. These are very simple. You've known this since grade school, that when, for any real number a plus 0 is a. When you add 0 to a number, you get that number right back. And similarly, the identity property for multiplication, for all real numbers a times 1 is a. When you're multiplying a number by 1, you just get that number right back. And those properties have all sorts of applications. We'll look at one at the end of the lesson here. But now I have 4 examples of properties, and I want to identify which property this is. This is very similar to the type of problem on properties you might see on the proficiency test. So in the first one here, I'm going to have 5x plus 0, and I get 5x. I'm adding 0 to a number, and I'm getting that number right back, or in this case, the expression 5x right back. Well, that looks like the one I just discussed right here. You're adding 0 to a number, you get it right back. That is the identity property. I'm going to abbreviate here, of addition. Okay? The next one over here, I am multiplying 3 times the quantity xy, and I'm setting that equal to the quantity 3x times y. It's not up on the screen anymore, but you should have in your notes. This is an example of the associative property, because what's happened is the order stayed the same, 3xy, not commutative, but you have regrouped. You have the last two grouped, now you have the first two grouped. So this is the associative property. And you're multiplying, so of multiplication. Okay, the next guy up goes right back to the one that we just looked at. 26 times 1 is 26. You're multiplying by 1, you get the number right back. That's the identity property for multiplication. And the last one, as you can see, I have 3 plus -2 equals -2 plus 3. I've changed the order, CO, change order, CO, commutative, and I'm adding. So this is an example of the commutative property of addition. Okay, let's wrap this up. The Boston Marathon is 26.2 miles long. How long is the marathon in feet? Well, this is an example of what we call dimensional analysis. You'll do this in some of your science classes as well as some of your math classes. Since we know that 1 mile is 2,800 feet, that if I put this over this as a fraction, it's the same exact amount. Anything divided by itself is just 1. So what I'm going to do is I'm going to take 26.2 miles, multiply it times 1. Well, when you multiply times 1, the identity property for multiplication says you get it right back. I should get the same equivalent amount. So what happens here is, think of it as cross canceling out, I multiply these two numbers together. There you go, 336 feet for the Boston Marathon. All right, now we want you to make sure that you feel comfortable with this, so practice, practice, practice.